This is going to be real informal, interactive. I want you guys to ask questions if we come across something that you want to know more about. This really is a piece of history that we're going to go through. Before I go any further, the piece of history that started this journey is sitting right up here, Jerry Bohannan. Some of you know him, some of you don't. A lot of the photos that are in here are from Jerry. He shared with us about a year ago. And so it's going to be a little journey in a timeline of our technology, how we started, how we did our work many years ago, and where we have evolved to. And a lot of you are involved with that evolution piece at this back end right now. And you can see how from the very beginning, we were really focused in on technology. We got to thank Jerry and Larry and those individuals early on in our history about having us focus in on doing things differently than normal, even way back then. So Dennis is going to drive. This is a piece of software I'll have him talk about. And it's a little bit different than a PowerPoint. And so, tell a little bit about it?
Yeah, this is a timeline software that lets you look at a large expanse of time, but be able to zoom into the individual events and kind of walk through the timeline and see where you're at in the timeline. And speaking of technology, we're doing some real interesting technology and displaying this up on the screen into the remote offices. This laptop isn't running the presentation. The presentation's being run by a Mac Pro computer on my desk on the 3rd floor. And we're webcasting this to a dongle on the back of the projector up there called Chromecast. And so hopefully it all stays together and works. But we did do a dry run in an owner's workshop, seemed to work okay. So.
Okay.
Do we need the lights out?
Yeah, you want to get the lights, Lou? Yeah, we're going to turn off the lights. It shows a lot better the images that we have on here.
Where's my food?
Just feel for it. Okay. I'm not going to read this to you. You guys will be able to see this, but this is really the beginning. Jerry Bohannan in 1959 formed the company Bohannan Stevenson Engineers, founded here in Albuquerque. Mr. Huston came along in 1963, actually moonlighting as he worked over at the Forest Service. And Jerry had convinced him to come on and do some photogrammetry for the engineering work that we were doing. And then in 1969, Larry joined the company, and we started the formal service of photogrammetry and mapping. This is one of our first ventures into aerial capture. Interestingly enough, Jerry and I were talking earlier, the pilot's name was Rocky, okay? And he did all the flying for us early on in those years. And you can see, talking back in 1969, doing aerial photography in the state of New Mexico, we were pretty cutting edge back then to be doing this. And we're going to go walk through a little piece of the process of what we did and how we developed base data for engineering. Obviously, the aerial capture was from the aircraft that we use, but part of the first steps that we did here to develop a map is that we found the ground control that all our survey crews laid out on the ground. Now, we do that same process today. I mean, we go panel control and we do the control work. We do it differently because we now have GPS. Back in the day, we had 3-man survey crews with chains and T2s and T1s. We turned angles, and it was a lot longer process than we do today, because today we can sit on a point and, 60 seconds later, 120 seconds later, we have a position on a point. Well, back then, it took a lot to get a position on a control point. We had to turn sets of angles, we had to run levels to them, and it took a lot longer to get a horizontal position and a vertical position on a control point. So here we would look for control, and then right after this, we would take that control and we would create, back in the day, we had to do glass plates of those images that were taken, and those glass plates were set in a machine where we would do stereo compilation on a Kelch machine. They were called Kelch plotters. And so all the orientation of that control was put into these glass plates. Then that information was run through an encoder, and this encoder gave us the information of elevation, okay, on those positions or elevations that we were developing from the stereo photography. From there, the encoded information was then plotted, okay, surface information onto pencil manuscripts. We actually had a piece of mylar, okay, you all know what mylar is, with a pencil, okay, that actually traced the contours that the compiler was seeing, and it would trace those contours, and then he would get up and he would mark what elevation that contour was. So it was kind of a manual, automatic kind of thing, but there was still some interaction where he had to go visually mark the contours that he was looking at. Then we would take that pencil manuscript and we would expose it in with a camera, okay, and we would expose the scribe coat. Scribe coat is this orange material, okay, so what happened is we would sit, once that pencil manuscript was drawn, we would then get on a light table, okay, that pencil manuscript was on the light table, then we would throw a piece of scribe coat on top of that pencil manuscript, and then we'd take a jewel tip scriber, would actually had a sapphire or a hard stone on it, and we would cut that scribe coat to reflect what we were seeing through the light table, the contours. And we would then mark the elevation of those contours, okay, on that same scribe coat. We would take that information after we were done, and we would expose it. And if you, later on you guys can stand up and see, but you can see hundreds and hundreds of lines on here that were manually drawn on that scribe coat, okay? This is what I call handcrafted work, okay? We couldn't do this more than one time. That card I gave you, first time right, there's a phrase on there. This is first time right, because we couldn't go back and do it again, okay? Once we had that scribe coat, we would expose it by the camera, then it would go into a photo lab. We had a pretty elaborate photo lab back on Carlisle. And every one of those scribe coats would be exposed to film, okay, through this photo lab process. And then the next image shows you.
Wait a minute, I crashed.
Uh-oh. Lou. Well, while Dennis is going through that. So, you know, we'd have this room, it's probably about this size, and we'd have probably, oh, I don't know, imagine 10 light tables in there with compilers, and we actually ran shifts. Okay, so there was an early morning shift. Some of you know, you up? Okay, some of you know the name Tom Mann. Tom Mann used to actually work at Bohannan Huston. He started at Bohannan Huston. And he was a person who started very early in the morning. He'd be there at 4 o'clock. So we had an early morning shift and then a later shift in the day. But we ran shifts, and we would scribe to produce all these scribe coats and all these base maps. What ended up being produced was this map, this mylar, okay, then that we could expose and get blue lines from it. Okay, so that basically was the process of developing a map back in the day. You still up? Yeah. In 1971, a new partner joined the firm, Jack Westman, and at that point in time, the partnership was Bohannan, Westman, Huston, and Associates. We were talking to Jerry earlier. This was probably one of the most prestigious projects at the time that we did in 1975. I mean, everybody knows what this is, the VLA, and if you guys watch movies, it's in every sci-fi movie that's out there. So we did all the site engineering, we did all the railroad, there was railroad tracks through this, we did all the site work. Jerry was telling me earlier that one of the most innovative things that brought us to the table on this project is we had a principal in charge of this project. Okay, back in the day we had a principal in charge, and so that was one of the things they liked about us. The other thing they liked about us was the building that we were in Carlisle. We actually were involved with the building and the design of that job, so they liked that building. And so that was one of the first, high profile projects that we did back in the day in 1975.
Was the client the Department of Energy, or?
Jerry, who was the client?
Let's see. It was the, I can't remember.
Yeah. I'm not sure who was totally involved with that. And then I came along in 1976. And when I was hired, we were coming, and you've heard this story, Brian has told us this story many times. We were coming off of actually being a pretty large firm. We were doing a lot of telco, Mountain Bell work in the Midwest all the way into New Mexico. We had grown to about 120 or so people. And I think one of the things that was an eye-opener at that time is that we had one contract, one client. And one day they came in and said the contract's over. Jerry and Larry had a very tough job to do because we had to lay off about 106 people from that. And so when I came on board, was the rebuilding of that, because that happened obviously before I was there in the late 60s, early 70s. And when I was hired by Larry, I thought, oh great, I'm gonna go into an engineering firm and it's gonna be real active. So I was hired as a draftsman, and I walked in and Larry took me to the drafting pool, and there was only one other person in the drafting pool, and there was a room about this big, and he was sitting at the very front. I was the second person, and so that's how I started. We started rebuilding the company at that point in time. I think it'd be safe to say that we learned the lesson of not putting all your eggs in one basket, and we started doing things differently. We started expanding into different services that we provided. Besides just telco work, we started doing civil engineering in all the disciplines. So that a big lesson, I think, came out of that. And here's some statistics, okay? Back in '76, we had 32 employees. Our total revenue that year was about $918,000. Cost per, or revenue per employee, was right around $28,000 back in 1976 with 32 employees. Soon thereafter, we started dabbling in computer technology. We hired a young lady named Leah Johnson, who was our key punch operator, and she would sit in there and she would key punch all these cards, right? And all these cards, what we were doing, when I first got there, engineers were doing calculations, and don't kid you, but there were stacks of paper, pieces of paper, 8.5 by 11, where they ran out the calculations by hand, okay, and there were stacks of paper this thick on all the calculations on the engineering design. So when we discovered computer technology, there was a place on San Mateo that compiled all the code that we wrote, Fortran, okay, and did the cards. We would take them over to San Mateo, and they'd compile the code, and then we'd bring back these rolls of computer paper, and it'd give us the answers. So we went from computation stacks of paper to this, to a much smaller stack of computer paper with the answer of what we were trying to do or trying to design. It was a big it was a big change for us. It was the beginning of computer technology for us. We threw this in as kind of a, you see, you don't see this today. There's not a trench box, right? But this is how things got built back in the day. OSHA was like, nobody thought about safety, but this is how things got done. This is one of our projects, putting in a water line.
That was back when gas station attendants would fill your car while smoking a cigarette.
Yep. Same kind of safety. Yeah. In 1978, we bought our first big computer, the VAX. We built a specialized room for it in the building, and we proclaimed that we were smoke-free at that point in time because that computer did not like smoke. And before that, many people in our building smoked. Then we found out we couldn't smoke, those who did. And so a new policy started in that we were smoke-free back in 1978. This is a piece of a document that Larry had given me on a strategic plan back in 1981. And what I thought was really interesting, if you read this, in 1981, we have very similar uncertainties in our world today. And it's pretty interesting that even back then, energy and the economy were a big thing, and that we were looking for a way to manage, and we came up with this strategic management concept, which, guess what, we use today. So, and in 1982, we formed Digenetics, which at that point in time, Leslie was not yet, but shortly thereafter, we started building the foundation of our computer technology and the way we were going to do our work. And this is a sample of the CAD environment and the commands that you used on a tablet to prepare or do your CAD work back in the day.
Is there anybody in the room that used Digimap? Yeah.
Yep. Tablet, those green tablets. Yeah. That was fun, huh? Pad Ed, right?
There was also a mapping tool.
Yes.
And an AT tool that was written.
Yeah, the very beginnings of really what we're involved now is a multi-user database. Back in that time, we were actually on the cutting edge of developing database technology. We were one of the front runners in that technology, and we competed head-to-head with Intergraph, which, you know, now is a huge company. In fact, we probably would still be in that business if we'd have started 5 years earlier. We just started too late, and we got eaten up by the big boys. But a lot of good things came out of that because it taught us that we could find answers to questions on the engineering side by applying technology and doing our work differently than we normal people were doing engineering back then. So, big step for us.
This graphical database really was a front runner of GIS systems today. And so we used to map military facilities and develop basically GIS systems for them prior to the days of Esri and other tools.
At that point in time, we were doing GIS projects in Germany, and we were doing military installations. Fort Hood was one of our big clients. Fort Leonard Wood was another location where we did work. So it did change the size of our business back then.
And this is the attribute part of that, but from what I recall, it didn't necessarily really get off the ground, Leslie?
No.
No.
No, that was the big push when I got here.
Yep.
1985, Jerry retires. It's been a while, Jerry. Here's some more statistics. We're trying to do a snapshot of statistics about every 10 years. So here in In '85, you see we've gone to 116 employees. Our revenue has gone very high, $5 million from what we had, $900,000 in '76, $43,000 in revenue per employee. We had a 545% revenue growth between that time, in that 10-year period. Again, I think it points to the fact that we were doing our work differently, and we were gaining a lot of efficiencies by doing that. And you'll see this statistical information kind of show you that pattern. '86, we moved to this building, and the green monster. Everybody used to joke around the entryway and the receptionist desk. It was actually that color. They say it's green, but you know. And here's the first step where we started dabbling in off-the-shelf software. Okay, CAD tools were now being put on the shelf, and you know, we had to deal with AutoCAD and MicroStation, and this is the beginning for us in migrating to those new packages away from where we were, which was our own homegrown environment. '91, we got our first GPS receivers. This really changed the way we did work in the field. It was very labor intensive to do field surveys, and when this technology came about, it changed how we did things. We could do lots more work like we do today. Right now, you don't find, sometimes we'll have two-person crews, mostly for safety reasons, really, not from production. And we do all our work with one-person survey crews. This was the beginning of that for us in 1991. In '92 was the first project we did for Santa Fe County. They are still our client. We are doing a project right now, or wrapping up a project for them, and they've been our client since 1992. We did the first digital ortho project in the country for them back in '92, and this was a big deal. This was about 3,000 square miles of orthophotography for Santa Fe County.
If I remember correctly, about a year prior to this, BHI has always had good partnerships with other mapping firms, and Earth Data was one of those mapping firms. And Brian Logan led Earth Data, and him and Larry got in a debate about the fact that there will never be orthos produced digitally. Larry's stance was that just couldn't happen. And then we did the first one in 1992.
Him and Brian quickly squared up on who was right? In '95, it was interesting. Dennis just mentioned a company, Earth Data. We actually were in a consortium of 6 firms. It was Earth Data, ADS, 3001, TAL, Horizons, and Bohannan Huston. And we did one of the largest ortho projects in the country, and it was for the Mississippi. Back in '95, the Mississippi had flooded. Some of you might remember, but it really created catastrophic damage along the Mississippi, all the way from the mouth of the Mississippi all the way up to the Missouri. And we were asked to do the mapping for the Corps of Engineers. And so all 6 firms got together and we did this project. It was a very, very successful job. All the data processing and the final deliverables were done here in Albuquerque. So everybody, wherever they sat in Oklahoma or back east where Earth Data was at, they sent us data, and then we would put the data together. We would develop the final deliverables, and all the data processing was done here. And major project for us.
How did you deliver it? What did it go on? Big drives?
I think no. Back in the day, it was DVDs and CDs, lots of them. That was the beginning of digital deliveries, but very, very took a lot of DVDs. Yeah, we did not do a hard copy delivery here.
One of the reasons I recall we put the whole data set together is we had the Digimap graphical database, and that was used in this project.
It was a big deal for us because we had that technology here in Albuquerque. Okay, 1995, you can see we're 131 employees now. We're $8 million in revenue, $64,000 per employee, and 168% growth in that time. So you can see how quickly we're growing, and you can see the influence of technology on that. 96, Digimap gets retired. And I think the remnants hang out in Leslie's office. I gave her a box the other day of stuff that I've been keeping over the years of Digimap. Yeah. Good. Yeah.
It lives on.
It lives on. And Leslie was very integral in the development of this. We did this for Intergraph, Storm and Sanitary. We use parts of this now too, don't we?
Yeah, still use it.
Yeah. So big thing for us.
Kind of from this point forward, this is a lot of spatial data specific things, but in '98 we got involved doing work for NEMA, which today is NGA, and they really pushed us pretty hard to stay abreast of technology. And so we started working more with workflows that worked with feature data, or moving from the CAD mapping systems and the Digimap mapping systems to GIS systems.
We first started doing this work, our facility, and most of you remember the facility on the third floor when we were doing classified work. But when we first started, we were in the basement where all the files are at, okay? And actually, we weren't in the full basement. We were in this little area that used to be a photo lab that we used to have here, and we were all crammed in there because we weren't sure we're going to be doing this work very long. Well, guess what? 12 years later, we were still doing the work, and it was very, very successful. And again, people came to us to help them with processing data and doing data because we had already established database environments. So for us to move in this direction, we had an advantage as to other people that were trying to do the work.
So we did the first county-wide LiDAR project in the country. There was smaller LiDAR projects, but we did a county-wide. We didn't know how we were going to handle all this dense LiDAR data back in 1999. So we wanted to go back to a database like we had with the Mississippi, Missouri River. And we decided to try Oracle because Oracle was the first database that started to understand spatial data, lines, points, and polygons. And many of you here have heard of FME. This is the first time we ever found it and bought a license of it. And I think it was about a year later, I remember talking to Larry saying, this FME is going to be a big deal for us. We should consider making an offer to buy that company. Even though I didn't know what I was talking about back then. But
And now, how big is the company?
I think they're a few hundred people, maybe.
Yeah. Very prestigious company. Larry retires in 2002. A lot of you still see Larry once a month. He comes around here. Yeah. And
So in 2003, we got real interested in digital cameras. This is when that transition happened for aerial photography. Everybody else was running around with handheld digital cameras, and it took a while for the large aerial cameras. These were $1.5 million cameras. Nobody was buying them. The film companies were lobbying against the digital technology. And our partners, 3001, bought a camera, and we did the very first project with this camera in North America. So another first, kind of akin back to the early 90s with Santa Fe.
this is something that some of you in this room know very dear and near to their hearts. When on that card you see first time right, on time delivery. One of the things that the government had us do on NGA work was it was very critical that we knew exactly where we were day in and day out, but not only where we were at, but what the quality was. So we created systems within the database that allowed us to do this performance tracking. So every day when someone got on a machine up in 310, they would log in and then log out at the end of the day, and we would know exactly how much work we did and how many errors we had. Then we could go back the following day, address the errors. And what was interesting about this is our quality got better because we were tracking what we were doing. This was a big deal for us with the federal work that we were doing. It was a requirement. We had to have it. We had to have it first time right, and we had to make the delivery on time. 2005, we're 211 employees, $26 million in revenue. So you see that really jumped from the 10 years before. $127,000 per employee, 318% growth. This is pretty amazing. If you can see from $8 million to this figure in that 10-year period, how technology has really influenced what we do. Validator was another tool that we use for automatic QC checking. I don't know, these guys up here ran it every day, and it was a very helpful environment to be in to satisfy the client's needs.
This is where we realized that architecture of FME would allow us to automate more things that were very much inspection or labor-intensive type processes. So that's why the Safe Software logo's there. This is just leveraging FME technology to do work, let the computers do work for us.
The difference from this to when I started and we did hand drafting, well, we could only do that hand drafting for one sheet one time. So the technicians were checking work all the time and telling the engineers, your grades don't work. This grade does not work. We got to look at this grade, because we didn't want to draft it more than one time. And so you can imagine some of those sheets took a week to develop. It took days. And so our validator were humans. They were the technicians that sat there and checked the engineering designs to be sure that they were correct, and talk about teamwork and communication between the engineers and the technicians. It had to happen because we couldn't afford to redo sheets. Here, the difference now is that we have to find ways to use automation to do the same things that we were doing as technicians with engineering design. So this is big difference for us.
So in 1999, we first used Oracle. Then we didn't use it after that because it was hard and it was cumbersome and it wasn't ready. But in 2006, after watching what was happening in our GGI group, we adopted this outside in the commercial part of our mapping business. We started working out of the database as well.
GeoMedia was developed actually by Intergraph, but we were a big piece of that. Leslie, Dennis, Brian Canance, John Nipper were individuals that actually went to Huntsville and talked with Intergraph and said, we need something so we can do our work, and we need something that can go into a database, and GeoMedia was developed, and we were part of that. There were meetings that went back and forth, and we were telling them what we needed, and they listened. And actually, this product came out of those meetings, and we still today use it.
So this is important. This is a big milestone in technology for us because we're an integrated company and we work on modified ground coordinate systems, which are not friendly with GIS databases. So we had to figure out how to deal with this in a geodetic way and not just with scale factors. And so this was the beginning of working through that with Alan Benham and others as we had to figure out the Earth mathematics to be able to represent ground coordinate systems in GIS packages. And this is where we started to try to figure out how to make the database work for us more by letting the database track what was happening to it, versions of work so we could rewind it, much like a tape player if we made a mistake, or I was hopeful one day we could fast forward it and have it send our bills and collect our money. And this is another big investment, and it's going to be leveraged more in the future once Chris really gets his arms around this technology. But this is taking FME off the desktop and making it a server, a service, so that behind the scenes it can be working for our company as soon as we figure out what we can automate, how we can get it to help us with QC across the company and the products that we make. Then we've all heard of geodesign. We started talking about this in 2011. And geodesign in the beginning was, how do we take some of these things we're learning about and doing in spatial data for our work and transfer them throughout the company where it makes sense. And as a good company, the first thing we do when we have an idea is we form a committee. And sometimes that really slows things down. But I will argue that the planning aspect of that helps accelerate it down the road quite a bit. And so after the committee spent a year and a half figuring out what we were going to do, we used the PMO techniques to develop a charter and come up with a budget and start to manage this geodesign initiative. And this graphic kind of ties back to the type of work we do. We build assets for people. We design assets, they get built, but we're part of the cycle, and we have a unique niche in that cycle because we also can collect data that can move through that cycle, through the design, through the construction, and through the management and planning aspects.
This is the beginning and implementation of building information into the database. We now house all the monuments or monument features in the database. So anytime a field crew goes out, we pick up a property corner monument, we set a monument, everything is put into the database. So as time has gone by, we have been building that database. So if we're looking for control, we know where it's at, who set it. And so it's a great tool moving forward. And it's just an example of how we're populating information into the database.
So from 2013 forward, we've been managing control data in the database. I think now we have over 3,500 boundary and monumented control points that are stored in geographic coordinates and ellipsoidal height, so we could always reuse them into any of our engineering projects that may benefit from them depending where they're at. And this is just more of that process.
And these monuments, you know, they're all the way from Colorado down into southern New Mexico, so they're everywhere we do work. They go into the database.
We also manage all of our coordinate systems in the database. So our database contains the ground geodetic coordinate system definitions that are linked to our BST project numbers for a project. So like the Gila Catwalk will have its own coordinate system defined and managed in our database, which is important because FME can read those. And we can use FME to move data back and forth from the database into the tools that we use in the proper coordinate systems. And this was the effort to train all the survey staff on how to work with the data that's in the database, the coordinate systems. And then this is part of the geodesign initiative to pick a database for our company to work in and to go through those discussions. And early on, thinking that was an important thing, we picked Oracle at the time. But as we learn and move forward, I think it's a better decision, and our group has talked about it, to stay database agnostic so we could work with any database anywhere. And one of the projects in geodesign will be to migrate the survey data out of Oracle and into our more common SQL server that we use across the company. The schema is about how do you store data in a database. It's the rules. And it takes a lot of work to do this. So the idea of all these things you're seeing, the schema, a data repository, all have to do with organizing data and store. It's the database standards, so to speak.
Aurora probably, was the biggest project we ever did. It was the whole globe. So we mapped and did work for NGA across the whole globe. We processed data for natural features. We did all the built-up areas. All the built-up areas are really cities across the globe. And so this was a huge endeavor for us. What's interesting about this job, this project, was we did it using different processing than we normally do. This took us into a different environment where we applied Mac tools to do processing. We did this work for Boeing. We did a huge amount of data in about a year, and it really was something to see because we touched all the coastlines of the world, we touched all the oceans of the world, and it was a piece of work that we, to this day, are very, very proud of. A lot of folks don't know about it, except for what I just told you, but it was something that people looked to us. We kept 4 other companies busy with the information that we produced, because without us doing the processing, they wouldn't have had work for them to do the final pieces that they were working on.
So like Silas mentioned, that project, we were stuck. We were getting data dumped on us. Lewis was standing up special servers for this work. These servers weren't able to work with this data. And on a whim, Rob Zur and I had both had the company get us Macs so that we could do more proposal writing. And we tried to run it on the Mac laptop. And the Mac laptop was able to get all the way through the process where the Windows servers were dying. And so we suggested to Boeing that we could probably process this faster. And they told us, do whatever it takes, send us the bill. And we bought these Mac Pro towers, which got us through the project. And I think today we're the only geospatial firm that uses Macs that I can find. When I talk to anybody, they're just kind of a little amazed, and I find that interesting.
Yeah. We're not going to tell them that what we're doing, though. Utility surveys, this is another thing that we're doing. I-70 in Colorado is a big transportation job for CDOT. In that project, we have picked up all the manholes with all the features going into those manholes with inverts, the amount of pipes coming in. We have done all the networking, again, because it's in the database. So all the manholes that we've collected on that project, which are a bunch, are in there, and they're being used today for the design build projects that are coming out. Phase 1 is out right now, and they're working on phase 2.
We also tried to figure out how do we use FME to take care of our CAD standards issues that we face. First in mapping, and soon in survey. But this is the data we store in the database, have FME write the deliverables and put it in the standards and do the quality checks for us so that we're not doing this manually. We're not having to pick blocks or cells manually. We're not having to, we're getting the FME tool to rotate them the way they're supposed to be based on what they're next to. So it's more productivity and QC type automation. This is another big piece of technology we just purchased back in August last year. This lets us take our GIS information, all this data in the databases, and put it out on the web in a secured manner so people can access it through web-enabled technologies. And that's an important path for our company as we move into the future. And the first place we really worked with this and what pushed us to do this was the Kinder Morgan project that some of you may have heard about. And Silas will tell you a little bit about what we did there.
Yeah, this is again an example of a client needing information very, very quickly. They were buying property up the project line as fast as they could because they needed to acquire the right-of-way. So they needed to know real time what had been purchased, how much had been purchased. So all of the information was going into the database, and as we were building the easements and the property, they were looking at those pieces to be acquired. And so it became a very important tool to the acquisition side of Kinder Morgan. And as most of you know, Kinder Morgan, the pipeline got put on hold, but one of the things that I think came out of this was they wanted to use this on the construction side. So we see a great opportunity for being able to feed the client the information that we're developing as we're doing the field work and the office work. It really makes a lot of sense for the client. 2015, 168 employees, $25,153,000 per employee, 3.8% revenue growth. So we're maintaining the size of revenue that we jumped up to. And if you notice, before it was 211 employees and now we have 168. So we're doing the same volume with less people, and that's because of tools and innovations that we use every day. I think that's a eye-opener for us, I think. We can see how we do our work is really effective to our business moving forward, and I think it's going to continue this way.
So we'd been pretty focused on how we do our work and the workflows for that. Rob Zur, Chris, Juan, others have really spent a lot of time developing new products now, using these technologies that can work on large data sets, oceans of bathymetric information or continents of terrain information, or the entire 3,000 square miles of Santa Fe LiDAR, and start doing real contiguous analysis without having to break stuff up into tiles. So this is a product that was made and sold to Santa Fe County. And in fact, tomorrow, Rob Zur and Earl Wright are doing a presentation on this at the Denver GIS in the Rockies meeting. To the folks that attend that conference. This is another important piece of technology for the company. It's called Apollo. So as we get more data bound, so we get more data bound, and that we were almost at the end. As we get more data bound, this is technology that helps us organize it and search through it.
And the sun will come out.
The sun will come up tomorrow. Yeah, we only had 3 or 4 more things left on the timeline, so they were just related to projects.
I hope that this kind of shows where we started and where we've come, and because of our focus on technology, I think it's one of the stories that we need to remind ourselves of, and that is that we should be curious about how we do our work. We should always be looking for things to do our work differently because of the groundwork that Jerry and Larry set for us and always being inquisitive about what we're doing and how we're doing it. We should always keep that in front of us. And I think this paints a pretty good story about what happens when you do that. So, questions? Comments? No? There's some drawings in the back that you can see, some old plans that were hand drafted, and you can kind of see what that entailed. And when I say it was handcrafted, it really was. You had to only do it once, and we didn't have that redo button. You know, it was time that you never recovered if you made a mistake. So I hope you guys enjoyed it.
Just one quick question, Dennis. You talked about the first big digital project and then the Mississippi River and then the first with a digital camera. Wasn't there several other projects that we were the first on when it came to mapping big areas, largest areas?
The North Central Texas Council of Governments in 2007 was the largest digital ortho project in North America.
At the time?
At the time. We did the first statewide project in the country, a big state, New Mexico. People were doing Rhode Island and stuff.
Yeah.
That's not even as big as Bernalillo County.
You can get that with one flight line.
That's right.
We did DR Cog, and big project, complicated project, because as you all know, it snows in Colorado, and so you have to fly that job just right, and trying to get everything captured all the way from the eastern side of Denver all the way to the west side, and try to get continuous coverage, being sure that the colors are captured or the images are captured at the right time. Doing all that, it's really tough, and we did a pretty good job on that project 2 times.
Yeah.
Very tough project. And one of the things that we're sitting waiting, right, Juan? MR Cog. We just interviewed for that last Thursday. And if we're successful, we'll be doing that for like the, tell me, 7th year or something like that?
Since when?
Our
first was
2004, 6, 8, 10, 12, 14.
Yeah, 6 years.
6, 7th.
Yeah. So a lot of the data that you guys use in your designs is really the outcome of our projects for these big MR Cog, DR Cog, and so it's the basis of all the information that you use for design. So important projects to us, and it has been like that for a long, long time at Bohannan Huston. We have done a very, very good job of collecting our data and using it multiple times.
Well, Dennis, maybe you can mention how our Santa Fe County LiDAR
Oh, yeah. The USGS is switching their standard. And so the Santa Fe County 2014 LiDAR project is the first to be delivered in that standard for that size of a project, a countywide project. So another first. We have a lot of firsts, and it's really unique for a company that's the size we are to be doing that. And we have to give a lot of credit to the tools we use and the ability to mine those tools and exploit what they can do.
The little card I handed out, those are little things that I picked up over the short period of time I've been here. And they, to me, they make a lot of sense. I mean, each one of these has a time and place that they were very important to us. Do more with less, especially when we struggle, okay? I'm sorry?
Oh, sorry. I was just saying ours have the same words but have different fonts.
Yeah. Take responsibility. That's another one. I think that each one of us has that ability, especially when we're working on our own projects. Use common sense. Man, that's really a good one. And then the other ones on the backside, those came out of the government work that we did. Those were really big drivers for us, driven down to us by the federal government, so, and the client. So anyway, some thoughts that I put down on paper for you, or a card.
I have a question.
Sure.
If you were gonna pick one technology or tool that you think is gonna be most important for us in the future, what would it be?
I think communicating to our client in the web, I think that really probably is the next big thing for us, because think about it, government is constrained with how they spend their money, so they can't build up big infrastructures of computers and have a bunch of GIS people in their footprints. So if we're able to do our work, host that work on the web, have them call us and say, I need this modified, can we change this? And we provide that service to them, I think that's a big deal. I think as time goes on and it becomes quicker, better, we do a better job of the data that we host, from the solutions in engineering, from a water hydrology perspective to bridge designs to whatever we are doing for a client. If we can do that over the web and get it to them quickly so they can make decisions. I think Dennis is involved right now with a conversation with James, with Wall. Okay, this is a developer, okay? That's kind of strange to hear that a developer really is interested in this and wants that information at their fingertips so they can make decisions quickly. I think that's going to be a big deal. I think if we're able to serve up the designs and the things that we're doing for Wall for that development, I think it's a big step. And so I think the web and how we provide information from the final design to the data that they use to make decisions is a big deal. Have fun this afternoon.
Thank you, Bill.
Mm-hmm.
Thanks, Tim.
Thanks, Dennis.